Hi. Can you hear me now? Hi, my name is Jay Runkle. Can you guys hear me? Good? All right. Hi, my name is Jay Runkle. I am a Distinguished Solution Architect at MongoDB, and I have been working on MongoDB's application modernization program for the last 2 years. And with me is Revathi. Revathi, want to introduce yourself?
Hi, everyone. I'm Revathi Narasimhan. I run products for the application modernization platform and super excited to share it with you all today.
So earlier, the speakers talked about their fondness of the movie Devil Wears Prada. This is application modernization, and we're fans of a different movie series called Mission Impossible, because this is application modernization after all. And I want to talk specifically about Mission Impossible 2. In that movie, Ethan Hunt is tied to a chair, he's being tortured, and his wife is sitting across from him with a gun to her head. And the reason why I bring that movie up is that it is an example of a movie where it starts at the end, and then the movie takes you back to the beginning and catches you up onto how Ethan got into that really difficult situation. And today, we're going to do the same thing during our presentation. We're going to start at the end, and we're going to show you a demo of how we do code transformation with MongoDB's AMP platform. We'll show code transformation, test generation, automated repair, and capabilities like that. Then we'll go back in time and show you how we set up this process and all of the upfront work and tooling and techniques that we created to make this whole platform work. And finally, we'll, at the end, explain to you in more detail what the AMP platform is. So let me go through and set up the dramatic scene that we're going to walk you through. So let's imagine that our task is to modernize this old legacy application. And we've, just for the sake of things, we've picked an e-commerce application. You know, it's got a website, shopping carts, all that type of thing. It's built 20 years ago or 30 years ago, so its backend is EJB and Java, and it's built on Oracle. The other thing about this app is was built by a team of people that no longer work at our company, and it's been patched over 20 or 30 years, so the code base is a little bit of a nightmare. So that's kind of the setup. And what we need to do is we need to get this application on MongoDB so that it's performant, it's AI ready. We're also going to build it on Java Spring Boot because we've got all young engineers who that's what they're comfortable with. It also gives us the ability to rapidly innovate and not have to worry about a lot of low-level details. And we want to set the stage so that we can scale this application up, deploy it around the globe to get real-time latency for all of our customers. And we also need to provide complete test coverage so that as we add new capabilities, we can easily validate that we haven't broken anything as we go along. And we're going to do this modernization using MongoDB's application modernization platforms, which, as Shilpa mentioned earlier, consists of 3 main pillars. One is some Gen AI tools, which you're going to see. It's also some techniques, some methodologies or design patterns, whatever you want to think of them, around applying these tools to rapidly accelerate the modernization of a legacy app. And it's also implemented by a team of really talented professional services folks that know how to apply these tools and techniques. So we're going to focus in this first set of demos on the tooling. As we go through this demonstration, I want you to think in your mind about how this process differs from some of the development you may have done using your favorite AI augmented IDE. So think about that as Revathi gives the demo. Revathi, the floor is yours.
Thank you all. Are you all ready to be amped up? Awesome. This is a live demo. So I'm going to pray to the demo gods that this thing actually works and the connectivity is okay. In the worst case, we'll shift to a video, but let's hope the live demo works. All right, to orient you towards this demo, I'm going to be switching to 3 windows. I'm going to show you what those are, and then we'll switch to the windows. The first one that you see in here is VS Code. This is where we will look at files. We'll look at the file that we need to modernize. That's a stored procedure package, Oracle package. We'll look at the new files that are modernized and generated, start showing up in VS Code. So we keep your eyes on this. Right. The second thing that I want you to look at is a set of tools. We're going to start off with the workflow engine. The workflow engine is where most of the action is going to happen for the climax, the dramatic scenes. We'll then go back and look at a few other tools. And then the last thing I want you to look at is a set of logs that will help you understand how this process is going to move. All right, let's start with understanding what we want to convert. What we want to convert, as Jay explained here, is the backend of a rather complex, old, poorly maintained e-commerce application. Pet store package, as simple as it is, everybody's probably used to this. It has several different stored procedures inside it. This talks about how a user places an order with a set of products, as simple as the retail application can get, which means that the methods in here that you see, or the stored procedures in here that you see, are about making sure that we know that the user exists, making sure that they have the right credit, that we can detect fraud when needed, log any suspicious activity, and most importantly, process the orders that are coming in. For the purpose of this demo, I'm going to walk you through what the process order looks like, because that's one of the most complex stored procedures that you have in this package. If you look at this package, in this procedure, you notice that we open a cursor here, and this is going to help us process the order items. And once you start with the actual stored procedure, you realize that this calls a bunch of nested procedures underneath it, methods in the more modern world. But if you look at this basically calls a check user exists, a check and update inventory, credit, and so on. It has some conditional logic. It tries to detect if there's fraud, and if there is fraud, it does a bunch of things. If not, it moves on and does a bunch of inserts as well. When it does an insert into orders, it does it by looping through the cursor that we just opened, going through those items and inserting them one at a time. If I took this entire package and fed it into an LLM, sure behold, I will have a set of files, but I wouldn't know what to do with them. So I'm going to now walk you through what this process looks like with our workflow engine. So let's shift gears, move on to the second window. This is our workflow engine. It's a bit of an eye chart, so I'll zoom in as we go. What you see here on the left are the components. These are the tools. When Jay mentioned that we have a whole bunch of tools that we started, this is what we talk about. We have something here called as the AMP tools. If I click in here, you see a bunch of tools that are listed in here. When our delivery teams work with you customers, they typically work in very restrictive environments, which means that they need to take these tools that are built in MongoDB, take them to your environment, make sure they run in your environment, and we don't build these tools in vacuum, we build them with you. We build them as we work through your particular code bases. So these are the tools that they go in and start using. These tools can be dragged and dropped into this canvas that you see in here, which is the workflow engine. And I can stitch those tools together and orchestrate a workflow. In this example, I already have a workflow that I've brought up here. This is a workflow that we will use for converting stored procedures to Java. The second T that Jay mentioned, technique, is something that we learn over time. We experiment and we work with many different customers over months and months of working together, figure out what specific use cases we need to address, and bake them into these techniques. Those techniques then show up in this workflow engine as codified workflows that you can execute. I'm going to start executing this workflow because it takes a little while for this to run, and then we'll go back in and look at the files that get generated. All right, let's start the process. We've begun the process here. As you can tell, it's running these components. I'm now going to walk you through what each of these different components do. The first component that you see in here is called as the Spring Boot generator. As Jay mentioned, the target stack that we want to convert our stored procedures is Spring Data and Spring Boot, which means the first thing that we need to know is figure out what entity classes and controller classes must this contain. This is the climax, so wait for the prequel in a little bit. At this point, I've already assumed that I need 3 different entities, users, orders, and products. And those are the ones that I'm going to create my Spring Boot classes for. So that's the first one. And this one creates the placeholder classes. Now I get to use a mouse and a mic. Let's see how that goes. All right. So like I mentioned, the second thing that you see in here is splitting. This is where we take this large package that we have, split it into stored procedures, and convert them one at a time. The third thing that you see in here is a list of package variables and declarations. Let's ignore that for now. That's just semantics. And then the most important piece starts here, which is a loop. This is where we loop through the different splits that we have and convert each of these splits one at a time. One of the things that Jay mentioned was it's important for us to convert, but it's far more important to make sure that what we convert is functionally accurate. The way we ascertain this is we make sure that we convert one stored procedure at a time, and we check for functional corrections as we convert. Dave mentioned this morning that we have both deterministic as well as non-deterministic ways that are implemented as a part of this workflow engine. This is the part where we actually invoke the LLM and have an agentic flow that's running behind the scenes for you. This does a few things. 1, it converts the stored procedure. 2, it verifies that it's functionally accurate. 3, it makes sure that every conversion that happens in succession in a way that the Java project can actually be built. And if the build doesn't work, then repair it through subsequent iterations. What does this whole functional correctness mean, right? Like I've talked about it a few times. What this means is we need a way to ensure that every split that we are converting is accurate. To do that, we use a process called database state-based testing. If I elevate this process and simplify it, it's basically looking at 2 states. It's looking at the state of Oracle before the stored procedure is executed. It's looking at the equivalent state of MongoDB. It executes the stored procedure. It converts that into a Java file, executes the Java file. It compares the states between Oracle and MongoDB at the end. And when that matches, then it's a success. It does this in succession. It does this in a loop. And as it keeps going through this, it makes sure that every piece that it converts is functionally accurate. This way, if there are errors in the process, you can catch it at the point where that error happened, instead of going back and debugging through hundreds of files of Java class. All right, now that I've talked enough about the stored procedures, let's actually jump in and see what files got generated. If I'll open up my VS Code, you now see a little green project here called demo project. This shows you that this is something that just got generated. We didn't have this the first time we looked at it. If I go back in here and see, I can see a whole bunch of files. When I jump into the files, these are things that are very familiar to folks that are familiar with Spring Boot and Spring Data. You've got a bunch of entity classes, controller classes, repository classes, as well as service classes. If I look at one of these to see what happens inside here, I can see that there's an orders entity in here, and this has a bunch of methods. Pay attention to the fact that we've got orders items inside orders entity here. I'll come back in here in the prequel to show you how this showed up. We have this invoking the orders repository, which invokes the orders service. And the methods that you saw there in the stored procedures, those methods are now converted. You can see that we have a new function inside this Java class. This method called the log suspicious activity, the fraud detection function. Thank you. And as you go through, you can see that it's added few other methods like check customer credit and so on. It's still processing this as we speak. How do I know this is still processing it? I'm going to switch here and show you what actually happened over this period of time that I was talking and walking you through the workflow engine. We first had an initial commit where we opened up the project. We generated a bunch of placeholder files. As you can tell here, those files were empty when we started, and it started populating 18 such files. We then started converting one stored procedure at a time. Remember, we talked about splits. These are the individual splits that are getting converted. And the code that gets added, so you can actually see here in diff as the code gets added. And each of these methods are now getting added in succession. And if I switch back into my terminal and show you how this works, you'll notice here, just give me 1 second. You'll notice here that we started off with the stored procedures. We were able to go through the constants and add those. We split those stored procedures successfully. So you see a bunch of stored procedure splits that we created. And then we started converting the first one, which is the check user exists, which is what you see in here. You see that it actually goes through multiple attempts. Like I said, when you use an LLM to convert, it's important for you to make sure that you can build and convert, and this does so with multiple attempts. So the first time I went in and I created this, I had a routine here to start the LLM generation. It went in, created, made the conversion happen, and you can tell here what's happening because we actually print all of this out. You can tell what it does. It tells you what kind of files it's adding into and how this works. If you scroll up, you'll notice that at this point, the LLM generation has been completed. When the LLM generation is completed, it tried to do a build. In this example, the LLM we are using behind the scenes is good, and the demagogues have been actually kind. So I can see that the build is successful at the first attempt. It does another final build as it starts executing all of the files together, and the builds are successful. Now comes the interesting part, the test generation and making sure that the file that was converted actually is functionally accurate. To do this, like I said, we look at the database state, which means we have to insert data into Oracle and MongoDB and compare those states. So you see here that we're actually starting to generate test parameters. And as you go into generating the test parameters, you'll notice that we were able to run the SQL file and initialize the database. We were able to initialize the initial database migration between Oracle and MongoDB. We executed the stored procedures. We tested the endpoint that got generated. This is the Java endpoint for check user exists. We noticed that the call was successful. We made sure that the values match between the original and the migrated versions. And then this tells us that this was successful. And we do this one procedure at a time. So, when I showed you the first one that was user exists, you have additional ones for log suspicious activity, and it goes through the same process. So as you can see here, this is a process that we use for taking this large behemoth pet store package, which had a bunch of stored procedures, and converted them into Java. Jay, back to you.
Excellent. Thank you, Revathi. So what I want to do now is could we have the slides back up there? What I'd like to do now is take a little bit of time and break down exactly what you just saw and explain to you why it works the way it does. So we've been doing modernizations, well, since the company began, but we've been focusing on using Gen AI for the last couple of years. And what we found is that it's really easy to create some really powerful demos. I'm sure everybody in this room has used some sort of agentic IDE or copied code into ChatGPT, and you get code out and it looks really great. But we're really talking here about legacy applications that were built and maintained and patched and hacked together for 20 plus years, and the code there is not so good. Usually what you find is procedures, functions, classes that are hundreds of lines long, maybe sometimes even thousands of lines long, spaghetti code that calls lots of other seemingly random other methods and procedures. And when you try and use an LLM to translate some of those really complicated pieces of code, you get code out, but it doesn't work. And then what happens is the human developer has to figure out why. So when we did our first couple projects, we were like, this isn't so good, this isn't working. So we're creative engineers, so we said, based upon our experimentation, if you have 50 lines or less, it works great. So what we did was the obvious thing, was we said, we'll just break it up. We'll take some really complicated blocks of code, 500, 1,000 lines, break it up into smaller units, let's say 50 lines each, send each one to the LLM, wire it all together, and guess what? It doesn't work, and then you're stuck in this position where a human developer has to, again, debug it, and all the value you get out of an LLM doesn't really help you. So what we kind of learned from this process is a couple things. One is you need to be really intelligent about how you break things up. The second is you really need to test immediately so that as you are doing code translation, you're immediately testing and validating what works. And you saw that in the demo as as our tooling was breaking apart the application and transforming it, it was immediately testing. Some of the things that Revithi didn't have an opportunity to show you is some of the kind of automated repair that we do as well. So if the LLM makes a mistake, it can automatically retry the transformation or retry the testing to validate that the code actually works. That's kind of one aspect of it. But basically, the idea around just vibe coding your way out of a legacy modernization doesn't work, and we've tried. And another aspect of this whole thing, which you saw in part of the demo, is that a modernization project consists of a lot of activities. Code transformation is just one step. You have to generate test coverage. You have to analyze the application to figure out how to break it apart into small units that you can transform and then immediately test. And then once you have done the code transformation, in our view of the world, to prove that you've actually done a successful job, you need to run the legacy application and the new modern application side by side and demonstrate that the input outputs are the same and the changes they make to the database are identical. So all of those different activities I've talked about are examples of tooling that we've created, some of which is deterministic and some of which leverages generative AI. Touch all that. So that's kind of a breakdown of what just happened in the demo you just saw. Now what we're going to do is we're going to catch you up on all the work that was done to set up that code transformation demo. So consider the situation where day one on a project, you need to modernize the app. How do you get started? How do you configure our tooling to make this work? A big part of that is the techniques and methodologies we developed to do that. And with that, I'm going to hand it back off to Revithi, who will demonstrate how we do those early stages of the modernization work.
Thank you, Jay. The climax was fun, but I made a whole bunch of assumptions when we got there. The first thing that I showed you when we started with this conversion is that I already knew what entities I had to start with. I already knew how these were persisted as collections in MongoDB. But that's not how the real world works. The real world, you go into a customer environment and you have a spaghetti mess of stored procedures. You probably also have a spaghetti mess of Java files. No one wants to touch any of these. You want to find out what you need to modernize, what functional slices make sense to modernize, at which points in time. You also need to find out how these things will appear in MongoDB. There's a whole bunch of things that you need to do before the transformation begins, and that's what I'm going to show you now. A lot of these are pure software deterministic tools that we've built, and we've assembled a whole bunch of them. I'm going to show you a few to illustrate this. When we started, Jay showed you that the backend of this application was done a long time ago. It was not maintainable. It was actually done using a technology called EJB. And for those of you who are familiar, EJB was a very popular technology a few decades ago. That's what the stored procedures are nested in. So in order for us to understand whether the business logic is in stored procedures or EJBs, you got to start with the EJBs first, because the UIs invoke that layer. So the first thing that we do is we look at the Java classes and we try and find out what's inside those Java classes. What kinds of dependencies are there? I ran a tool called Java Source Code Analysis. I'm not going to show you the actual running of the tool here, but I'm going to show you the results of what the tool produced. What the tool produced was basically the fact that we have an EJB action, which is the top level class that's being invoked by the UI. That EJB action has a whole bunch of other classes that it's connected to. So you see the dependencies here. What's interesting here is what we see at the bottom. At the bottom, we see here called a method called perform that sits inside that EJB action class. And the perform method in here calls a stored procedure called process order. When I ran this analysis, I understood that what I have here is fairly complex EJB code. I also have a stored procedure called process order, and then I need to extract that stored procedure and figure out what's inside it. When I showed you the demo, I showed you a package that already contained the stored procedure. But how did I even get to that? How did I even know how many stored procedures are in there so I need to split? To do that, we have the second tool that I'm introducing here called the stored procedure dependency analysis tool. This basically tells me that the process order stored procedure has a whole bunch of other stored procedures that it's invoking. We saw fraud detection, log suspicious activity, check customer credit. All of these are different stored procedures that we were able to detect that process order has a dependency onto. And it doesn't stop here. I can go here and look at what tables are connected to that. So in this example, I recognize that the process order stored procedure is working with a bunch of different tables in my database schema, in my Oracle database schema. I see orders, which has order items underneath it. I see products, which is a part of an inventory, and I see users. This is how I figured out that these are the underlying database tables that the process order method invokes, and these are the operations that it does. The next question, now that I have these tables in Relational, I need to figure out what's the optimal model for storing them in MongoDB. I need to do that modeling before I begin any conversion. Because when I convert, it's important for me to know what those collections are so I can model them in my Java Spring data layer. To do that, I'm going to take you to the next tool. This might be familiar with a lot of you. This is a product that we've had for a while. This is the MongoDB Relational Migrator. And if I go into the project that I have in here, what you notice on the left is the Oracle tables. So we see orders connected to ordered items connected to products, inventory, and users. And I used the Relational Migrator to suggest the MongoDB schema for me. And it gave me what you see here on the right. It showed me that I can take these orders, I can nest ordered items as an array in here. And if you recall, when I actually converted the classes, I actually had a list in there for order items. I knew that because my modeling here stored these mappings in a form that I could use as an input to my conversion. You can also see here that this is connected to two other collections, the users collections, as well as the products collection. So when I did this analysis, when I began, I was able to look at my Java code. I was able to figure out all the invocations of stored procedures or any inline SQL. Second, I was able to jump in, look at the stored procedure and what its dependencies were and what tables it accessed. Third, I was able to model it. So I was able to figure out what my collections should look like and how they might move. And one of the things that I'm not showing in here is the same Relational Migrator tool can be used to migrate your data. So one of the things that you saw in the climax that we did was we actually were able to compare the states between Oracle and MongoDB. The reason we're able to do that is we're able to migrate the data at different points in time as snapshots using the same tool. So in this very short demo, I've shown you at least 4 tools that are independently existing, in addition to a whole bunch of tools that showed up in this workflow engine. This is a very, very small subset of all the tools that exist. And going back to what Jay talked about, there are many, many steps of a modernization journey. And what you saw here again is just a small snippet of code conversion. Hopefully that explains how this whole picture came together. Jay.
Great, thank you. So what we're going to do now is we're going to do the beginning of the talk that you probably expected when you came in the room 30 minutes ago and kind of wrap this all up together and explain what the app modernization platform actually is. You probably got some insight after the demos that Revathi's done, but let me kind of pull the whole picture together. So first, let me talk a little bit about modernization. This is probably the intro you expected when we started the talk. Modernization is actually really hard, and the tools that Revathi demoed and the technique that she showed, the methodology, is all created to solve this really hard problem. So what is this problem? First, you have really complicated legacy architectures, lots of different components, relational database, stored procedures, probably some sort of cache to get around the fact that n-way joins are really expensive, and maybe a search engine added on to add some more query capability that the relational database can't handle, and then some runtimes, JBoss, WebSphere, who knows what else, an ORM, some really old version of Java that is out of support, and a whole bunch of libraries that are causing your compliance teams all sorts of headaches. And all those technologies that I just mentioned, for each of your apps, there's a huge amount of variation. Whether you might have one app that's using Hibernate, another one that's using Ibatis for ORM, different runtimes, different versions of different databases. So there's a lot of complexity and a lot of different legacy technologies. The next challenge is that much of your team probably graduated from college in the last 10 years and isn't really familiar with those legacy technologies. They don't know how to write PL SQL, and they never wrote JBoss or used WebSphere or whatever. They know Java Spring, and they know Node.js and all kind of web development and all sorts of the modern type of development tools. So that's kind of a next challenge, is you don't have the right team. And then the next challenge is that this application, it was a monolith when it was designed, so it was already a really complicated, interconnected set of code, and then it's been patched and maintained and features added over the last 20 or 30 years. So it's really a giant ball of spaghetti. So what we kind of have demonstrated with this tooling and technique that we've created is a process by which how you can essentially understand that structure and begin to tease it apart, translate small units of code, immediately test, so that if there is a code translation error, a human individual can easily fix the problem, or maybe even an LLM in an automated way can fix the problem. So to MongoDB, modernization requires a lot of different activities. It's not just code translation, right? So one is just going from that legacy platform to a modern technology stack. The next is replacing an old relational technology with a modern data platform like MongoDB. It typically involves taking a monolith and decomposing it into a modular architecture, whether it's a modular monolith or set of microservices. And then, equally important, creating test coverage so that as you're doing the transformation, and then later on when you add new capabilities, you can continuously validate that the application works as desired and you hadn't broken anything. And then finally, the last step there is just doing the actual code transformation from legacy code to modern code. You might be wondering, like, why don't I just rewrite this application? And in our view, you have invested as an organization 20 or 30 years of making sure this application works right, fixed any edge cases. So the value of translating the code and modernizing it is that all of that business logic that was developed and tuned over many years of hard work by large teams of people can be moved into a modern architecture and not lost if you do a re-implementation. So to kind of summarize, the application modernization platform consists of a set of both deterministic and Gen AI-based tooling for doing the kind of all of the tasks required for a modernization. And those tools are applied based upon a series of techniques or methodologies that we've developed that have been proven to be really effective at accelerating development processes. And then finally, this is all orchestrated by a team of highly trained, talented modernization engineers. The other kind of really powerful thing about AMP is that it is continuously getting better. So we have organized this innovation loop, we call it, so that as we deliver projects, as we develop new methodologies or enhance tools or come up with new ideas for tooling, those lessons learned are fed back into our engineering team, and those new capabilities very quickly are encapsulated in either the tooling, the technique, so that the next project goes even faster. And what we've seen at customers when we do these projects is a really high degree of acceleration or developer productivity enhancement. So if you're looking at specific tasks like code analysis or generating test coverage or code transformation, we're really able to accelerate those significant tasks, those tests at a high rate. When you look at like the end-to-end delivery of a project, typically we're doing these projects in 2 to 3 times faster than the customer could do it themselves, or if the customer works with their favorite SI. So this has really dramatically changed the business processes for a number of our customers, enabling them to either like improve customer experience and satisfaction or capture market share, or whatever their particular business challenge might be. So with that, looks like we have about 8 or so minutes to answer any questions. Revathi and I are going to put the headphones on. In order for us to hear you and for the folks online to hear you, we need you to go to a microphone if you have a question. So it looks like we have a question here. We need a microphone. I can't hear.
Can you hear me now?
Yeah, I can. Yes, good.
Jay, thank you so much. Excellent presentation.
Thank you.
And good question. I've noticed that you guys had a COBOL on one of the slides.
Yes.
Do you provide COBOL support for transformation right now, or it's part of the future roadmap?
So yes and no. If the COBOL is running outside of a mainframe, we have a number of customer projects where we're doing modernization of COBOL apps. If it's a mainframe-based COBOL application, we have a partner that we work with that uses a very similar methodology and tooling, but they're kind of experts on mainframe development, and we work with them on those types of applications.
Hello, thank you. Good presentation. So you have relational database as a part of From, right? So as a consumer feedback, what would be super helpful is to know how to move from relational database other than the models, but also the sizes. Because for example, relational database, I can have a join or document which is based on 50 tables joined, and it comes up to more than 16 megabytes, and that's what we deal with. And that's what our consumers are expecting to get from us. So it would be super helpful to get like a pattern on how to move from what we have, going around or working around those type of restrictions to how do we get there. So those type of things would be super helpful for us. Thank you.
Sure. I can take this too.
Okay.
One of the things that we are realizing as we build AMP is that queries come in many forms. And most of the queries are just as complex as you described them. They have many different joins. They go across multiple different tables, many different indexes to work with. And we need to figure out not just the order of joins, but the order of predicates that are usually driven by a search that sits on top of them. What we've been trying to do is understand what these patterns look like and take some of these learnings from AMP and feed it to our database engine. Our database engine is now working on features that helps us with optimizing query performance and view performance of what looks like a largely relational query to start with, because we understand that modernizing UIs might be harder, modernizing different kinds of predicates might be harder. So we're getting there. We're actually seeing this in action, and we're seeing this with the customers that we work with. So those are some of the tools that we are working as well. That we have tools for view optimization and query optimization that we are building both as a part of AMP as well as feeding into the underlying database.
Hello, can you hear me?
Yes.
Hi. I work for a large financial company, and we are very concerned about security and not sending our code out the door, et cetera, et cetera.
Yep.
So we have Mongo in-house, and we are not going to be using Atlas. ARM, is that just an Atlas, or can this be put into organizations?
Great question. So the AMP tooling that that's all good. Yeah, the AMP tooling that Revathi showed typically runs on a developer workstation, in your firewall on site with you, so it's not running in cloud. The one exception that we have to talk about is that we do require a very recent, powerful LLM to do some of the analysis and code transformation. And that typically is hosted in one of the hyperscaler clouds. The way we deal with the security there is usually a large financial institution like yours has a relationship with one or more of the cloud providers and has already established a contractual relationship that says they won't, log any of your queries that contain code. They won't use it for training or anything like that. And then we also configure our tools to use your particular endpoints that you've created within your account at that cloud provider so that everything is managed and controlled by your security teams.
Thank you.
Look, looks like there's a question there.
Hi, thank you for the presentation, guys. So I have one question. At what point in the migration, modernization, do we say, okay, maybe the project is too complex, maybe it's gonna cost too much, or maybe it's gonna take too much time, as opposed to just create a new application and a new code. So yeah, what would be a good reasoning to determine that?
So I think I mentioned this at the end of my presentation. There is definitely a balance. One of the reasons that we advocate for the code transformation, the modernization of the logic is that usually with a legacy application, you released it 20 or 30 years ago. When you first released it, you ran into all of these edge cases and there were these fire drills. When you patched it, after a while, you got everything settled out. If you do a completely new build, then you're going to go through that same experience and pain again. The real value of our methodology and our tooling and the people that we bring is that we can do this extremely fast. So you might be saying we're looking at this giant mess of an application and say it's going to take us 3 years to modernize. We'll come in and scope it and say, hey, we can do it in 8 months or something like that. And then that may change the calculus on whether you rewrite or essentially do a modernization like we prescribe. So I would, if you're interested, definitely reach out to somebody on the AMP team and we can help you understand what it would look like to use AMP. And then you also have a good understanding of what your own development processes are and you can compare.
If I may add to that, Jake,
Yep.
One of the things that our analysis tools gives you is complexity analysis. So you can use the analysis tools to get a sense of how complex your applications are, and you can stagger this over time. So you don't have to pick up the largest piece of application to modernize at the first go. You can modernize the smaller parts, the less critical parts, before you start picking up the larger pieces.
So I think we have time for one more question. Yeah.
Hello, can you hear me?
Yep.
Thanks, Jay and Revati, for the wonderful presentation. I just have one quick question. So we have a lot of legacy code living with us, but to start with, I thought let's pick up the smallest piece, which is a reporting tool written in VBA long back. So I was thinking, what kind of support do you already provide for transforming VBA into some modern tools?
So you said VBA, Visual Basic, basically?
Yeah.
So we haven't done Visual Basic before. Like we've been mostly focusing on Java and C#. That's kind of where we have our expertise. But we would be, a lot of the methodologies, the technique that we use would work for Visual Basic. We'd be happy to meet with you and kind of give you a feel for what it would look like. But 2 years ago, we had nothing and we built all of this infrastructure for Java and C#. So we would definitely be interested in talking about it.
We mostly have like 95% in C#, but just this 5%, this is smallest piece to to pick up and finish it off quickly. So I thought let's try the smallest thing first and then move forward.
Happy to have a conversation about it. Well, it looks like we're out of time now, so I appreciate everybody for joining.
All right, folks, thank you so much for joining us for this session and learning more about AMP. We have another session starting on this stage at 11:45 with Mikiko, and that will be Beyond Context Windows, Building Agent Memory Systems for Intelligent AI. If you're going to stay at this stage, you can keep your headphones. Otherwise, please return them to the table at the back. Thank you so much.